Hi, the next topic is prediction and confidence bands. So the confidence intervals for all possible value x0 is a band. So remember that the confidence interval is defined for any fixed point x0. For example, at this point, the expected values, this red one is the regression line, and the expected value is here. And then we have some band, for example, 95% confidence interval is here. But we can calculate the confidence interval for any point. So at this point, band may be here. At this point, band may be here. And at this point, maybe band is here. Actually, if the x0 is far away, especially we have the x0 outside of the range of the data, generally the band is wider. And if we connect these confidence intervals, it becomes band. So this is called the confidence band. So a confidence band is a band for the regression line because by definition, the confidence interval is the section that the regression line intersects with that specific x0. So if we connect this, then this is basically the area where regression line may move. So if this is the 95% confidence band, the regression line is within this confidence interval with 95% probability. So of course, sometimes it misses the confidence intervals. For example, if data is just special, then sometimes it misses this confidence interval. So this part is outside of the confidence interval. But if confidence interval is 95%, at 95% confidence level, the 95% of the time regression line is within confidence interval. And the prediction interval. Prediction interval is also can be calculated for all possible values of x0. And if we make it also, that this becomes a band. So generally, prediction band is wider than confidence interval, confidence band, because each prediction interval is wider than confidence interval. So if we connect this, then generally shape is like this. So this is the band for points. So if we have new observations, 95% of observations are within this prediction band. So sometimes it misses, but this one misses the band, but the 95% of the time, the points are within this band. So this is called prediction band. Yeah. And both bands gets wider as x gets farther away from x bar. So the center is around here, maybe x bar is around here. So if the x0 is far away from x bar, generally the confidence band and the prediction band gets wider. So this is because the extrapolation is difficult. So if the data range is from x is 10 to 50, it's harder to predict the value when x is equal to 60. Even at x is equal to 50, still, if majority of observations are around 20, 30, 40, it's slightly more difficult to predict the value for x is equal to 50. Yeah, so this is the one example of the confidence band and prediction band. And confidence band is clearly a kind of the hyperbola because it's the range for the line can move. So the regression line looks like this, or sometimes this, or so on. So the curvature is clearer. And the prediction interval, still it has curvature, but we cannot also almost recognize it because, yeah, one thing is it's wider. So the green one is the prediction band. Yeah, so that's the difference between prediction band and confidence band. So prediction band, you can see we only have the one observation out of the band, and probably there are maybe 50 points. So it's pretty good. Oh, maybe 2 points outside of the range and 1 on the boundary. So if there are 50 observations, then it's reasonable to expect that 2.5 observations are outside of the band, prediction band. And this is a sample code for prediction band and confidence band. So it's a little bit complicated. So at first, we specify the range for X and the range for Y. So this is the data for the condominium price data. So the price, Y is price. And X is the square footage. So we explain the price by square footage. So the range for X is about, yeah, so we can just specify the variable so that we can calculate the range. So range is given by a vector with 2 entries, so minimum and maximum. So it output the minimum of square footage and maximum of square footage. So this is the range function. Okay. And the Y range, okay, so yeah, we can calculate it, but the Y range, if we just the range for Y, it's not sufficient because the we calculate band. So even if the observations are within narrow range, still the confidence band and the prediction band can be wider. So that we have to have some margin. So I just hand-picked 2 values, negative 200 to 2,000. The negative 200 means the negative $200,000 in $1,000. Yeah, then actually we have a convenient function, the predict function, to get the predicted interval, prediction interval and the confidence interval. So if we specify interval is equal to C, then we get the confidence interval. And if we specify INT is equal to P, then I mean the quotation P, then we can get the prediction intervals. And the CI, so this predict function have basically, so outputs the 3 columns. So CI is at first the expected value, for example, okay, so suppose that this is 95, then the lower bound of the confidence interval and upper bound for confidence interval. So this is the CI is the sample size times 3 matrix. So maybe lower bound is 20, maybe 92.1, and upper bound is 90, maybe 7. Expected value is at the center. Yeah, then we have, okay, so next observation, maybe expected value is 150, and the lower bound is maybe 146.5, and the upper bound 153.5, and so on. So this is the how, okay, maybe one more point. Maybe this is 80, and this is 76, and this is 84, and so on. So this is the object CI, C sub I, generated by predict function. Then we want to make the graph by using these 3 vectors. Okay, so we have seen in the previous figure that we have basically 3 lines for confidence interval. So the expected one and the upper bound and lower bound. Okay, so we have to draw these 3. But before that, we sort the values by square footage. Because, yeah, this is a little bit complicated. So we have basically, yeah, so we calculated confidence interval for each observation. So basically, theoretically, we have to calculate the confidence interval for each possible value of X, so infinitely many values. But in practice, we cannot do that. So that we just pick up the existing observations, X2, x1, x2, x3, x4, and so on. And we make an interval. So the center and the upper bound and lower bound, center, upper bound, lower bound, center, upper bound, lower bound, center, upper bound, lower bound, and so on. And we have to connect this one by one and in order. Okay, so if x1, x2, x3, x4 is in this order, so what will do? What R do? So that is, okay, connect x1 to x2 and x2 to x3, then x3 to x4, then and so on. So actually this makes very messy multiple lines. So we have to order it first. Then we have to connect x1 with this x4, that is second, the smallest one, then x3 and x4, so on. So that we have to avoid the we go back and forth. So that's why that we use order function, so that if, okay, so in this example, this one comes first and this one comes second and this one comes third and so on, if we only have 3 lines. Okay, prediction interval, we have to do the same. Then after that, the code is, okay, so this is just a function to save the output for JPEG file. Then that we plot. Okay, so plot is just usual scatter plot function of square footage and price. Then we specify X limit and Y limit. So we have to, okay, we will overlay the multiple graphs. So that we have to use the same X range and Y range to have the same consistent scale. So we have to specify this every time. Then the next one, this is our new code probably. So mat lines. So basically we can draw the multiple lines with one function. So sorted square footage, then CI. So basically we have the 3 vectors, expected value, lower bound, and upper bound. So we draw the 3 lines at the same time. Then the color is 1 to 2. So the color 1 is black and color 2 is red. So the 1 is just regression line, so we make black. And the color 2 is red. So we describe the confidence interval in red. And the next one, we also overlay the prediction band. The code is the same. And the color 133. So the expected value, anyway, it's the same as the confidence interval. So just make it as black. Then after that, we use the color 3. Color 3 is green. So the green prediction band will be added. Then we got some legend. The location of x-axis is 1000, location for y-axis is 2000, and the confidence interval and prediction interval, well, maybe you can put confidence band and prediction band. The line type 1 is the solid line, and the color is 2, 3, so red and green. Then we output the figure, so device off. So this corresponds to the JPEG function. If you start JPEG function, you have to close with the device off function. Then you can make this graph. Yeah, so it's a little complicated, but we can do this way. And exercise 2 and exercise 3, I will ask in the quiz or the homework. So exercise 2 is just to generate the confidence interval with using the predict function. And the exercise 3 is to calculate the confidence band and prediction band, but using the original formula rather than the predict function. You can see the confidence interval and the prediction interval was, can be calculated by the formula this way. For example, the confidence interval is calculated by this. So if you put all possible value of x naught, actually, usually that we calculate the all observed, all observations x naught, we calculate the confidence confidence interval, then we connect it. Then we can make a confidence band. If we only have 5 observations, maybe the curve is not smooth. So you may want to put the more, x values, x not values. But generally, if we have 30 or 50 observations, maybe you can plug in just existing observations. That makes the smooth enough the confidence bands. Yeah. So yeah, so this is how to create the confidence bands and the prediction bands.